This is lesson 22 in module 3, and we'll be finding factor pairs and defining prime and composite numbers. Let's start with the array that shows 1 times 8. So there's one row of 8. So we can write this as multiplication problem. 1 times 8 equals 8. The 1 is called a factor. The 8 is called a factor. And the answer we get when we multiply is called a product. Now we can show 8 in a different way with a 2 by 4 array, which means we have 2 rows of 4. And we can write this as a multiplication problem. 2 times 4 equals 8, where 2 and 4 are the factors and 8 is the product. Let's look at another one. Let's look at these 3 arrays: a 1 by 18 array, a 2 by 9 array, and a 3 by 6 array. In the first one, we have one row of 18. In the second one, we have 2 rows of 9 each. And in the third array, we have 3 rows of 6 each. In each of these arrays, we're showing a total of 18 objects. We're just arranging them in different ways. So each of these then becomes factors in a multiplication problem equal to 18. So if we list the 6 factors we have here in numerical order: 1, then 2, then 3, the next largest one is 6, then 9, then 18. We can say that all of these numbers are factors of 18. And we can pair them up so that one factor times another factor is what gives us 18. So 1 times 18 is 18, the same as this one. 2 times 9 is 18, and 3 times 6 is 18. So each of these is factor pairs. And notice that as soon as we got to halfway through our list of factors, we did 1, 2, and 3. The other 3 were automatically paired up. So when we're looking for factors, we only need to go to the halfway point, and we know the rest of the factors are going to be matched up as pairs. Let's look at another one. Let's look at 2 times 8 equals 16. So we know that the factors in this equation are 2 and 8. We're also going to think of other number multiplication sentences that can give us a product of 16. Well, we can always do 1 times the number itself. So we have 1 times 16, so that gives us factors of 1 and 16. We can also do 4 times 4, which gives us 16. I can check the other numbers in between. 1 times 3, there's nothing to give us 16. 1 times 5, nothing to give us 16. 5, nothing to give us 16. So at this point, we found all the possible factors. So we went halfway through and we've gotten all the factors. Now if we put them in order, we can match up the factor pairs. And this is one where the 4 is multiplied by itself. It becomes its own pair. But we've now found 5 factors and their associated factor pairs. Let's look at another one. Let's look at 1 times 7. 1 times 7 equals 7. Is there a 2 times something that equals 7? No. 3? No. 4? No. And 4 is more than half of 7, so I know I don't have to go past the halfway. So the only factors I can find for 7 are 1 and 7. Let's try 1 times 5 equals 5. Are there any other 2 numbers I can multiply together to get 5? 2 times something? No. 3 times something? 4? No. 4 times something? No. And to 5, and I've already done 5. So my only 2 factors for the number 5 are 1 and 5. And we have a special name for these kinds of numbers. They're called prime numbers. And prime numbers are numbers whose only factors are 1 and the number itself. All other numbers are called composite numbers. So these are prime numbers. Composite numbers are ones that have at least one factor other than the number in itself. So these are prime numbers, and everything else is composite numbers. Let's look at 3 numbers: 23, 35, and 48. Let's start with 23. So for 23, I have 23 times 1, times 2, times 3, times 4. I can always go all the way to times 11, which is half of 23, and I can't find any other factor pairs. So for 23, the only factor pairs are 1 and 23, so that makes this number prime. For 35, I have 1 times 35, but I also have 7. I also have 5 times 7, and of course the inverse 7 times 5. So my factor are 1, 5, 7, and 35. And because there are the factors other than 1 in itself, this is composite. Now for 48, I can do 1 times 48. I can do 2 times 24. I can do 6 times 8. I can do 3 times 16. So as you can see, I have a lot more than just 1 and 48 as the factors. So 48 is composite. Okay, let's use what we've learned to work some problem set problems. So our directions here say record the factors of the given numbers and multiplication sentence and list in order from least to greatest. Classify each as prime using the letter P or composite using C. The first is done for you. So for the number 4, We can do 1 times 4 is 4, 2 times 2 is 4. So our factors are 1, 2, and 4, which makes this number composite. You try number 6, B, and do 6. Okay, for 6, we can do 1 times 6 because we can always do a number time itself. We can do 2 times 3. So our factors would be 1, 2, 3, and 6, which makes this composite. Try C. For this one, we can do 1 times 7, which is 7. And that's the only two numbers we can multiply together to get 7. So the factors are 1 and 7, which makes 7 prime. Try the number 9 for part D. For this one, we have 1 times 9. We also have 3 times 3. So our factors in order would be 1, 3, and 9. And because we have factors other than 1 and 9, that makes this number composite. Try E. For 12, we have 1 times 12. We have 2 times 6. We have 3 times 4. There's nothing for 5. We've already used 6, so now we've done the first half, so we know there aren't any more factors. So we have 1, 2, 3, 4, 6, and 12. So definitely more than just 1 and 12, so that's a composite number. Try the number 13. We can do 1 times 13, but that's all we can do. So the factors are 1 and 13, which makes this number prime. Try the next one. For 15, we can do 1 times 15. We can also do 3 times 5. So our factors would be 1, 3, 5, and 15. And since we have factors that are not just 1 in itself, it's composite. Try the number 16. For 16, we can do 1 times 16. We can do 2 times 9. We can do 4 times 4. So our factors would be 1, 2, 4, 9, and 16. So this number is composite. Try the number 18. For 18, we can do 1 times 18. We can do 2 times 9. This should be 8. Sorry for that. We can do 3 times 6. Nothing times 4, nothing times 5. We've already done 6. Nothing times 7 or 8. We've already used 9, so we're halfway through. So those are all our factors. So we can order them as 1, 2, 3, 6, 9, 18, making this number composite. Try the number 19. For 19, we can only do 1 times 19. So our factors are 1 and 19, which makes this number prime. Try 21. For 21, we can do 1 times 21. We can also do 3 times 7. Nothing times 4, nothing times 5, nothing times 6. We've already used 7. Nothing times 8 or 9 or 10 or 11. That's half of 21, so we're done. We can do 1, 3, 7, 21, which makes it composite. And try the number 24. For 24, we can do 1 times 24. We can do 2 times 12. We can do 3 times 8. We can do 4 times 6. Nothing times 5. We've used 6. Nothing times 7. We've used 8. Nothing times 9, 10, 11. We've used 12. So we're halfway through. So that's all of our factors. So we have in order 1, 2, 3, 4, 6, 8, 12, and 24. So definitely a composite number. And let's go ahead to number 2. It says find all factors for the following numbers and classify each number as prime or composite. Explain your classification of each number as prime or composite. Let's do the first one together. So factor pairs for 25, we can do 1 times 25. We can do 5 times 5. So this would be composite. Because 5 is also a factor. You try 28. So we can always do the number time itself, 1 times 28. We can do 2 times 14. 3 times 16. 4 times 7. 5, no. 6, no. We've used 7. Not for 8, 9, 10, 11, 12, 13. We used 14. So we're halfway through. So this is also composite because there's more factors than 1 and 28. Try for 29. So we have 1 and 29. Nothing times 2, 3, 4. As we go all the way through the numbers for up till half of this, which would be 14 or 15, there's no other factors. So this is prime because the only factors are 1 and 29. And that's our definition of prime, that the only factors are 1 and the number itself. Okay, let's try number 3. All right, so all the prime numbers in numerical order are less than 1. So 1 times 1, 2 times 1, that's the only way to make that one. 3 times 1, 4 is also 2 times 2. 5, the only way to make that. 6 we can make is 2 times 3, so that's not prime. 7 is prime. 8 is 2 times 4. 9 is 3 times 3. 10 is 2 times 5. 11 is prime. 12 we can make several ways. 13 is prime. 14 is 2 times 7. 15 is 3 times 5. 16 is 4 times 4. 17 is also prime. 18 is 2 times 9. And 19 is also prime. Now, Brian said that all prime numbers are odd. So by using our list, we can see 2 is an even number, but it's also prime. 2 is even, but also prime. because we can only get 2 by multiplying 2 times 1. Okay, try number 4. Okay, Sheila has 28 stickers to divide evenly among 3 friends. She thinks she'll have no leftovers. What do you know about factor pairs to explain if Sheila is correct? Well, if she's correct, there has to be a number that we can multiply times 3, her 3 friends, and get exactly 28. So let's try. 3 times 7 is 21, so we can go a little higher. 3 times 8 is 24. We still haven't made it to 28 yet. 3 times 9 is 27. We're almost there. 3 times 10 is 30. So 28 would fall in here somewhere. But so there's no number that we multiply by 3 to get 28. So Sheila's not correct because she could give each of her friends 9 stickers, but there'd be 1 left over because she has 28 stickers total. So there's no way for her to do this and not have any leftovers. Okay, that's the end of lesson 22.